Hello everyone and welcome back to the channel. In this video we were going to take a look at this tiny buck converter, a step down DC to DC converter that can deliver up to 2 amps and is quite efficient actually. Another characteristic of this buck converter is that it has a very low quiescent current, so it is great for battery projects and battery operated things. Let's take a look at it, take measurements and see if it is up to the task. So it all started with a project of mine. I wanted to build an Arduino circuit that uses two movement sensors and does a thing. This is going to be powered from 8 AA batteries, so we're going to get about 12 volts, and all the conventional step down converters like this one, the LM2596S, had a quiescent current in the milliamps range, which is unacceptable for a battery project. It will drain the battery very fast. In this case, the Arduino just operates for a couple of seconds and goes into sleep mode, so the same thing applies for the two sensors as well. So everything goes in the microamps range, but the problem was the DC to DC converter that powers the Arduino had high quiescent current and wouldn't allow the project to operate for years as it is at this time. So let's take a look at this tiny DC converter, DC to DC converter, that it is supposed to be a direct replacement because of the pinout to LM series, LM78 series regulators. So now let's take a look at the IC datasheet. You can see it is a synchronous step down converter with a very impressive 3 amps output, although our little board is listed as 2 amps, and it is very efficient. It is listed as a low quiescent current for notebooks, flat panel television and monitors. Okay, so the supply current without the enable pin is 1 microamps, which is not what we want. The supply current quiescent is about 180 microamps, which sounds very low compared to the other step down converters. Now let's take the measurements on the bench and see if that is correct, and we will take it from there. Let's take a look at the implementation that the company has done for this specific IC. It is made from Sunrom Electronic Technologies. It is situated in India. Hello to all my viewers from India. And it is a nice implementation because you get an adjust pot and also some predetermined voltages: 1.8, 2.5, 3.3, 5, is that 9 or 6, I don't know, or 8, 12, and you can use the pot to adjust your output voltage. You do need to cut the adjust here or remove the small potentiometer, and I see they have listed as 3 amps, but the one in the picture has a different coil there. Let's take a look at the measurements at the bench. Now here is my setup. I have connected in series the voltmeter, the multimeter in milliamps range, hooked up everything. Small warning, it will have some blinking lights here, I will cover it. My power supply is set to 12 volts, that it is the input for this project, and let's fire it up. So the Arduino goes into startup modes and consumes about 2 milliamps, and now it goes back to sleep mode and settles at 430 microamps, 730 microamps, which I realize something is not going well. Let's test the circuit. If we bump one sensor, it gives some warning lights, etc. So I'm going to turn off the power supply and remove I have removed the Arduino, so now we only have the buck converter connected, and it is on, and in our case, as you can see, it is consuming about 260 microamps. And it is at this point I realize that all my calculations had been wrong by an order of magnitude. This will last a few months actually, and if we add up the sleep current of the Arduino and the sensors, the whole thing is going to run out of batteries in 4 or 5 months. So I have found a different replacement for the step down converter, and we will take a look at it now. So the solution to the problem is this MCP 1702 low quiescent current regulator. As you can see, it claims 2 microamps quiescent current, 250 milliamps output, which is plenty for the Arduino and the 2 sensors, and you can see it is mostly for battery powered applications. Let's go straight away and test it. Unfortunately, it does not have the same pinout as the LM series volt regulators. Here is our little TO92 regulator. So we need ground is this one, in is the middle one, and the output. The only problem with this one, which is right on the edge, and it says here, is that it is good for up to 6 cells, so not 8 as I'm going to use it, but highest voltage is 13.7, or sorry, 13.2, which should be alright with alkaline batteries. Back to our operation here. So plus we've got 12 volt set, 12 volt set on the power supply. Let's start it. That's interesting. This is quite a lot actually. We do get 370 microamps. It is more than the other one. Let me switch to this scale. Oh, that is really interesting. So mystery solved. We do need a 22 microfarad output capacitor to make it stable, and as soon as I plugged in the capacitor, the quiescent current went down to 2.5 microamps, which is what the datasheet says, about 2. So that is really excellent for battery powered projects. I will remove from my PCB the old one and use the new one with bent pins. So here we are. Although I did not manage to solve my Arduino power consumption problem, what we can say about the MCP 1700 series is that they are really great. So what I've done now, I've fired up the module just by using the one sensor, and you can see it is down to 12 microamps, which is great. And if we remove that sensor as well, same thing, about 12 microamps. It should be, I have a power measurement for the battery, and that bumps up the power consumption. So all in all, it is designed to be used with battery powered things. Smash the like button if you found this video interesting. Thank you for watching, and see you on the next one. Bye.